Welcome to the Deep Dive, where we explore groundbreaking ideas and unpack the most profound insights from new research, just for you. Today, we're diving into a paper that honestly dares to challenge a real cornerstone of physics, Noether's theorem. You probably learned that conservation laws, energy never being created or destroyed, things like that, are about things staying constant. They reflect deep symmetries in the universe. But what if conservation isn't really about sameness at all? What if it's about a constant dynamic unfolding? A kind of dance.
That's exactly the core idea in Philip Randolph Lillian's really radical new paper, Conservation Laws and Symmetry. He introduces his unified coherence theory here. In this work, it's not just tweaking our understanding a little bit, it's a complete U-turn, really. He's proposing that asymmetry, not symmetry, is the fundamental conserved quantity.
Wow, okay, asymmetry as the conserved thing, that's a big claim. So our deep dive today is going to walk you through his coherence symmetry algebra, the CSA he calls it. And we'll see how this framework kind of unexpectedly links fundamental physics to things like biology and maybe even consciousness itself.
That's the goal.
You should get hopefully a clearer picture of a theoretical model that could genuinely shift how we see reality. It even brings in concepts like the observer function, weaving it right into the fabric of the universe. So yeah, let's get to it.
Okay, so to really appreciate how different Lillian's idea is, let's just quickly recap the standard picture, the familiar ground. Noether's theorem back in 1918. It's foundational. It basically states that for every continuous symmetry you find in a physical system's behavior, there's a corresponding quantity that's conserved.
Right, and you've probably heard these examples, like, if the laws of physics work the same today as they did yesterday, that's time translation symmetry, then energy is conserved. Or if they're the same here versus, over there, space translation symmetry, that gives you conservation of linear momentum.
Exactly, and rotational invariance, things looking the same no matter how you turn them, that connects to conserved angular momentum. Even something like electric charge conservation comes from a deeper symmetry, a gauge symmetry.
So the classical view boils down to conservation laws are the physical proof of underlying symmetries. It's all about preserving sameness in variance.
Precisely. But Lillian steps in and says, well, hold on. Is that assumption really the whole picture? Is it truly complete?
And this is where he flips the script. His main challenge is this. Asymmetry, not symmetry, is the more fundamental thing being conserved. It's a bold move, asking us to rethink what conserved even means.
Yeah, and it's really important to clarify what he means by asymmetry. It's not chaos, not just random imbalance. He defines it very specifically as the structured differentiation of coherence. Think of it like a dynamic tension that actually gives rise to things, fields, forces, particles, dimensions.
It's even consciousness, he mentioned.
Even consciousness, yes. It's about the dynamic flow, the process of formation, rather than a static state.
Okay, so let me see if I follow. Instead of things staying the same because they're perfectly symmetrical, Lillian's saying the universe is constantly changing, constantly transforming. But it's the pattern of that change, the structured differentiation or asymmetry, that's actually conserved throughout the process.
You got it. It's shifting from conserving a static form, like a perfect sphere, to conserving the dynamic process that creates forms, like conserving the flowing structure of a river, even though the water molecules are always changing.
That makes sense. So how does he formalize this? It sounds quite philosophical.
Well, he introduces a mathematical framework, the heart of the theory, the coherence symmetry algebra, or CSA. You can think of it as a set of rules where symmetry, asymmetry, and coherence aren't just concepts, but active operators, almost like forces that interact constantly.
Okay, operators. Let's break those down. First is the symmetry coherence operator, S.
Right. S represents the sources or dynamics that stabilize things, that harmonize and preserve the coherence that already exists. Think of it as the status quo maintainer, in a way.
Then there's the asymmetry resonance operator, A. And you said this isn't disorder.
Correct. A is the driver of change, of emergence. It represents differentiation, phase shifts.
Yeah.
It's how new structured coherence gets formed or differentiated from the old.
And the third one, C.
Yes. The coherence emergence operator, C. This is really where the action is, you could say. C is the result of S and A interacting. It governs what Lillian calls coherence modulation. It's basically the engine that generates all the new structures that emerge from that interplay.
So S preserves, A differentiates, and C is the emergent result. How do they actually interact? You mentioned rules, commutation relations.
Exactly. Commutation relations are just a mathematical way of describing how these operators combine or affect each other. So there are rules for how symmetries interact With other symmetries, that part is actually similar to existing physics, like Lie algebras.
Okay, standard stuff there.
Then there are rules for how asymmetries interact with other asymmetries. This is fascinating. It shows how different kinds of structured differentiation can combine constructively.
Constructively, so not just canceling out?
No, not at all. It's structured. For example, he suggests things like chirality, left or right-handedness interacting with torsion, which is a kind of twisting, could generate a specific new helical field structure. It's ordered emergence.
But you said the real engine is the interaction between symmetry and asymmetry, S and A.
That's the core generative process in this theory, yes. When S meets A, they don't destroy each other. Lillian argues they interfere constructively to generate fundamentally new coherence. This interaction is how things like new force fields, new particle states, maybe even cognitive events like an idea suddenly clicking into place, how they emerge.
And this interaction isn't always the same strength.
No, exactly. It's governed by these structure constants, but Lillian proposes they aren't fixed numbers.
Yeah.
They're dynamic, they depend on the context, on the field itself. He calls one a coherence tension scalar, for instance. It's a very responsive system.
Okay, that's already a lot to wrap your head around. S, A, C. But then he adds a fourth operator.
He does. There's the metacoherence operator, which he writes as U xi hat. This completes what he terms the coherence 4 tuple, written as C, A, J's, U, X, von.
Identic coherence, what does that one do?
So, takes it a step further. It's not just about a structure emerging. That's C. It's about how that newly emerged structure itself can then resonate, transform, and influence things at an even higher level. In physics, he relates it to things like hyperdimensional coherence modulation, the appearance of new complex resonance patterns.
And outside physics, you mentioned biology and consciousness.
Right. In biology, he speculates, could relate to how complex biofields coordinate development, something like developmental field intelligence, the self-organizing principle in an embryo, maybe. And for consciousness, it's linked to recursive awareness feedback, how consciousness can observe itself, reflect on itself, and create coherence at that meta-observer level.
Wow. So it's like layers of emergence building on each other.
Exactly. These four operators, S, A, C, and A, they form this continuous closed generative loop. It's recursive. The coherence C generated at one level can interact via neurocomb to create the next level of metacoherence. It's self-generating complexity.
Okay, so this algebra, SAC, isn't just abstract math for Lillian. He's saying it actually describes reality unfolding.
Yes, he proposes it manifests across different ontological layers, almost like different levels or phases of reality.
Layers. Tell me about those.
Okay, first is the omnilectic layer. This is the absolute foundation, perfectly balanced invariant.
Yeah.
Here, asymmetry is only latent potential before projection into what we think of as reality, like a perfect void, maybe. S plus A, 0, he writes.
Okay, the baseline. What's next?
Then comes the Hall electric layer. This is where asymmetry starts to show up, but as field modulations, creating resonance differentials. Think of it as the potential starting to ripple, creating active fields.
Fields, then particles and interactions.
That's the relational layer. Here, the asymmetry gets encoded into specific interaction rules. This is where we see particles emerging, forces acting between them, and even complex biological differentiation starting. This is closer to the physics we know.
And the final layer.
The derived layer. This is basically the reality we observe around us, the crystallized coherence forms. And here's a key point. Things that look like broken symmetries in standard physics. Lillian sees them differently.
How so?
He suggests they aren't fundamentally broken at all. They're just the residual effects of this fundamental asymmetry conservation playing out, being modulated by coherence. So what looks imperfect is actually part of a deeper, conserved dynamic pattern.
That reframes things quite a bit. And where does the observer fit into these layers?
Crucially, the theory explicitly includes an observer function and a consciousness function. The observer function tends to reduce overall symmetry and create localized asymmetry, like when you measure something and collapse its possibilities. The consciousness function, perhaps related to awareness or reflection, tends to restore symmetry, diffusing that localized asymmetry. Their interplay, Lillian argues, is what actually conserves the overall asymmetry across all these layers.
So observing isn't passive, it's part of the conservation mechanism itself.
Exactly. It's an active role in the dynamic coherence.
This is fascinating, but how could you actually test or measure this? It sounds very theoretical.
Well, this is where it gets potentially practical. Lillian introduces something called coherence index labels, represented by lambda. Think of them as markers, or maybe steps on a ladder, classifying the level of emergence a system has reached. They identify these emergence thresholds across dimensions, coherent states, and those ontological layers we just talked about.
A ladder of emergence. What are some steps?
Okay, so at the bottom, L0 is pure symmetry. Like the unbroken vacuum state, nothing has emerged yet. Then maybe L is gauge resonance. You have stable field symmetries emerging, like the U1 symmetry of electromagnetism.
So basic fields are low on the ladder. What happens higher up?
As you climb, Euless is a bifurcation threshold. This is where significant asymmetry appears, structure really starts differentiating. Then up there could be mass shell formation, coherence condensing into recognizable things like particles with mass or even stable biological forms.
And consciousness, where does that fit?
Much higher. He proposes O5 corresponds to sentient recursion. This is where self-reflective intelligence emerges, systems that can be aware of their own awareness.
Sentient recursion. Interesting term. And the top.
The latter theoretically goes to dish and total invariance, an ultimate state where symmetry and asymmetry perfectly balance out again, maybe beyond our ability to observe. But the key thing is, these aren't just descriptive labels. He provides a predictive threshold resonance equation.
An equation to calculate the out.
Essentially, yes. It factors in measures of a system's symmetry, S, asymmetry A, and coherence C, with some weighting factors. It allows scientists, potentially, to calculate a system's emergence phase, its unvalue. This could let you predict or diagnose when a system might be about to undergo a major phase shift or exhibit some new emergent behavior.
Okay, now that sounds testable. Can we apply it to anything concrete?
Lillian gives some conceptual examples, like the early universe, just after the Big Bang, would be dominated by symmetry, so it would have a very low, maybe even negative. He throws out a number like -3.8, just illustratively, meaning no coherent emergence occurs yet. Basically just primordial soup.
Makes sense. What about a biological example?
Think of an embryonic polarity, a stem cell starting to differentiate, setting up the body axis. That system is actively generating structure. It would have a much higher on, perhaps say 6.8. That higher value would indicate that processes like bioelectric recursion and organ field shaping are active. The system is well along the path of emergence.
And the consciousness example, a moment of insight.
Right. Imagine a neural network, or even your own brain, having a sudden realization, achieving self-awareness, or solving a complex problem. That represents a very high level of emergent coherence. Lillian suggests this could correspond to a very high on, maybe 9.1 or more, indicating high sentient recursion. A new, complex, coherent understanding has just popped into existence.
It's almost like putting a number on the complexity or awareness level of a system.
Kind of, yeah. And he even mentions an emergence tuning matrix, suggesting this framework could, in theory, be used proactively, not just measuring, but maybe designing systems, quantum computers, AI, artificial life, to reach specific emergence thresholds by tuning these S, A, and C parameters.
Engineering emergence. That's a bold idea. You also mentioned something about geometry, Finsler geometry.
Yes, briefly. The theory extends into this less common type of geometry.
Yeah.
Standard geometry, like Euclidean or even Riemannian used in general relativity, assumes the metric. The rule for measuring distance is the same regardless of direction. Finsler geometry relaxes that. The metric can depend on the direction you're moving or looking.
How does that connect to coherence and observers?
It allows the theory to naturally incorporate observer-relative coherence. Because the geometry itself can be direction-dependent, it means the way you observe, your perspective or interaction, can literally influence the effective geometry of the situation. It provides a mathematical basis for the observer not being separate, but intrinsically part of the system's dynamics.
Okay, bringing this all together then. The big picture implications are pretty huge. Our familiar conservation laws aren't just about simple symmetries in spacetime anymore.
According to Lillian, no, they're deeper. They are field resonance invariants. They emerge from this whole recursive coherence cast, this interplay of SAC, which is itself modulated by how the observer couples to the system, by the resonance tension and the changing topology.
So things like mass, force, time, even the number of dimensions we experience, they aren't fundamental constants in the old sense.
He proposes they are expressions of resonance structuring in a coherence-driven universe. They emerge from this deeper dynamic process. It really aims to be a unifying theory, potentially connecting quantum gravity ideas with biology, AI, and consciousness studies. It's incredibly ambitious.
And he ends with this idea of a coherent civilization. What's that about?
Yeah, it's a call to shift our societal focus. Instead of just trying to fight entropy and decay, entropy avoidance, he suggests we should aim for resonance participation, actively engaging with and fostering these processes of coherent emergence and transformation.
It's definitely a different way to look at things. So recapping the core shift. We move from thinking conservation is about static symmetry, things staying the same.
Seeing it as the conservation of dynamic asymmetry, the structured potential for change, all powered by this coherent symmetry algebra, SACA.
And this potentially reframes everything from particle physics to how life organizes itself to the nature of our own minds.
It really does open up new ways of thinking.
Which leads to a pretty provocative thought to leave everyone with. If conservation isn't about preserving sameness, but about facilitating constant, coherent transformation, what does that imply about how we should view change and growth in our own lives or in society?
And maybe even more fundamentally, if you're very active observing, your consciousness isn't just a passive spectator, but an active participant shaping the reality that emerges. How does that change how you choose to engage with the world? What reality are you helping to co-create?
Definitely something to chew on. A fascinating dive today into a potentially revolutionary framework.